Hello everyone, welcome back to my channel. So we are starting with solving quadratic inequalities. So up till now what we did was we were solving quadratic equalities or quadratic equations that were y is equal to ax square plus bx plus c. So normally what we do if we are solving a quadratic equation, we find zeros of this quadratic equation. So what do I mean by zeros is we take this quadratic equation ax square plus bx plus of c and equate it with 0 and find those particular values of x which give us value of y as 0, right? But we have a range of values. So if I show you by a graph, only these 2 points give us y as 0. If we substitute only these 2 points p and q in the equation, we get y as 0. The rest of the range, so before p, the quadratic equation has y which is greater than 0. From p to q, the value of y is less than 0. And from q and forward, what we get as y is greater than 0. So this is our y. These are the values of x. So when we substitute any value from over here from this particular set of interval, so we get a positive y. If we substitute from this interval p and q, we get a negative y, and after q again positive. So these are the different values of interval. So these are inequalities, right? So whenever I will get a quadratic inequality, for example, if I'm getting ax square plus bx plus c is less than 0, so answer for this particular inequality will be when x is greater than p and less than q, right? Because at p and q the quadratic equation is becoming 0, and in between p and q we are getting y as negative or less than 0, right? And if I take ax square plus bx plus of c greater than 0, so what I will get two intervals when x is less than p and when x is greater than q, right? So these are the two set of intervals. Now if I am given ax square plus bx plus c is less than equal to 0, so I'm also including values of 0, so I will take p less than equal to x is less than equal to q, and if I'm taking ax square plus bx plus c is greater than equal to 0, so what I will take is when x is less than equal to p and when x is greater than equal to q. So these are the two different sets in which we can achieve the value of quadratic equation can become greater than 0. The major point over here is, first of all, what we need to do is we need to find these zeros, and then we'll break the complete x-axis into 3 intervals, and then we'll check which particular interval is satisfying our inequality. Okay, so for that, step number 1 is finding the factors of the quadratic equation. All right, so we are already given this question in the form of factors. So from here we get x is equal to 0 or x is equal to 3. So we break our real line into 3 intervals: when x is less than 0, 0 and 3, and when x is greater than 0. So if we take something when x is less than 0, for this, if I substitute that value over here, what I will get is, let us suppose we can also take as x is equal to -1. We can pick one value from this interval. If we substitute it, -1, -1. So the value that I'm getting is -1, -1 minus of 3. So this gives us, so we are getting +4, and this is not less than 0. So this particular interval will not give us value less than 0 or equal to 0, right? Let us check second interval. If we take any value from this, if we, let us suppose we take 1. If I substitute 1 over here, so if I am taking x is equal to 1, and if I substitute that, I get 1 times 1 minus of 3, that is -2. Yes, this value is less than 0. So this interval is right. Next interval, if I take 4, so 4 times 4 minus of 3, 1, that also will not be less than 0, right? So I hope it is clear. And the interval that we'll get is when x is greater than equal to 0 and less than equal to 3. So this is the interval which is satisfying our inequality, right? Let's move forward. We have two factors over here, and what do we need is when x is greater than 0. First of all, let's find the roots. So x minus of 3 and x plus of 2 is equal to 0. From here what we get is x is either 3 or x is -2. So we break our real line into three intervals: -2, 3, and what we want is positive value for this complete quadratic equation. Now, if we take any value from this first interval, so if I, let us suppose, let's take x is equal to -3. If I substitute that, so what I'm getting is -3, -3, and -3 plus of 2. So this will give us -6 times -1, which is 6. And 6 is actually greater than 0, right? So this satisfies the required result. This interval, all the values of this interval will satisfy this inequality. If I take any value from interval -2 and 3, if I take 0 from here, if I substitute that, I will get a negative value. For example, if I take x is equal to 0, what I will get is 0 minus of 3 and 0 plus of 2. So we get -3 plus 2, that is -6. So this is not greater than 0. So the interval -2 and 3 will not satisfy the result. If I take when x is greater than 3, if I suppose, let's take x is equal to 4. So if I substitute this, 4 minus of 3 and 4 plus of 2. So what I get is 1 times 6. So I get 6, right? So this is actually greater than 0. So interval when we take x is greater than 3, that is also our desired result. So we only need value greater than 0. We don't need equal to 0. So the interval that will satisfy all these are when x is less than -2 or when x is greater than 3, right? So these two intervals satisfy this inequality. So whatever value I take from these intervals, I substitute over here, the result will be greater than 0. I hope it is clear. Let's move forward. Now, factors are x minus 6 and x minus of 4. And what we want from this quadratic equation is all those values of y, values of x for which we get y less than or equal to 0, right? So with the help of factors, we get zeros, those are 6 and 4. So this real line will split into three parts, and zeros are 4 and 6. So if I choose any real value from this first interval, let's take x is equal to 0, what I get is 0 minus 6 and 0 minus of 4. This gives us 24, and 24 is not less than 0, right? So we'll not choose this. If I take 5, which is in between 4 and 6, so if I take 5, what I get is 5 minus of 6 and 5 minus of 4. So this gives us negative 1 and positive 1, that is negative 1, right? So this is negative 1 is actually less than 0, right? And if I take any value from the last interval, so let's take x is equal to 7. 7 minus of 6 and 7 minus of 4. So what we get is 1 and 3. So 3, and this is also not less than 0. And we also need equality over here. So less than and equal to 0. So interval from 4 to 6, this will satisfy this inequality. So our desired result will be when we are taking 4 is less than equal to x is less than equal to 6. So this inequality will be satisfied from this interval. I hope it is clear. Let's move forward. Factors are 2x plus of 3 and x minus of 2. And what we want is value of y should be less than 0. Now what I will take, x is equal to negative 3 by 2 and x is equal to 2. These are the two zeros of this quadratic equation, first of all. So negative 3 by 2 and 2. We got three intervals. What we want is value of y should be less than 0, right? That means what we will do, we'll take any value from intervals and substitute it over here and check whether we are getting a negative value or not. Let's start. So negative 3 by 2 means negative 1.5. We can take negative 2. So when we take x is equal to negative 2, if we substitute it, what we get is negative of 4 plus of 3 and negative 2, negative 2. We get negative 1 and negative of 4. So this is actually 4 positive. So this is not less than 0. So we will not choose this interval. X is equal to 0 in between negative 3 by 2 and 2. So if we substitute this, what we get is 0 plus of 3 and 0 minus of 2. This gives us negative 6, right? And it is negative 6 is actually less than 0. And if I take third interval, what we get from here is if I choose x is equal to 3. So we get 6 plus of 3, 9, 6 plus 3 and 3 minus of 2. So from here we get 9, and which is not less than 0. So the set of range for x is, now since it is less than 0, not less than equal to, so we'll take negative 3 by 2 is less than x is less than 2. So this should be our answer. Alright, let's move forward. Now if I find the zeros of this quadratic equation, so the values of zeros will be when x is equal to 5 and when x is equal to negative 6. The real line is breaking into three intervals, negative 6 and 5. So these are the three intervals. We'll take one value from the first interval. So x is equal to negative 7. If I substitute it, what I get is 5 and plus of 7 and minus 7 plus of 6. So this will be actually negative. So now slightly I will improve. I will tell you fast methods to know which interval we'll choose. So from here we can observe that if I take negative 7 and substitute it over here, something will be positive, right? Because sign changes, and negative 7 plus of 6 will be negative over here. So positive and negative will give us negative value. So we'll not take this interval. I can also solve it. So we get 12 times -1. So from here we get -12, right? As I told you, if I take value from this interval 0, if I substitute it over here, so 5 and plus of 6, that is some positive value 30. So if I take x is equal to 0, 5 minus of 0 and 0 plus of 6, that gives us 30, right? So yes, this is the desired result. And if I choose something from the third interval, we get, if we take 6, we get 5 minus of 6 and 6 plus of 6, that is -1 and 12, we get negative of 12, right? This is also not the interval that we want. So our interval is -6 is less than, and since equality is over here in the sign, so we'll also take, so less than equal to x is less than equal to 5. So this is our answer. I hope it is clear. Let's move to the next part. We have over here these two factors. So if I try and simplify it, what I will get is 1 minus 3x is equal to 0, and 2x plus 1 is equal to 0. From here I will get x is equal to 1 by 3 and x is equal to -1 by 2. So these are the two zeros of this quadratic equation, and this will divide the real line into three parts: -1 by 2 and 1 by 3. So these are the three intervals. What we need is value of this quadratic equation should be less than 0. Let's identify which interval is that. So if we take x is equal to -1, if I substitute it over here, what we get is 1 and plus of 3 and -2 plus of 1. From here what we get, it's 4 times -1, that is -4, and this is less than 0. So yes, this interval will take. If I take some value from this second interval, that is x is equal to 0, if I check for that, we get 1 times 1, which is 1, and it is greater than 0. So we don't want this interval. This interval is giving us the value for y which is not desired. Let's take third interval. So if I choose x is equal to 1, and if I substitute it, what I get is 1 minus of 3 and 2 plus of 1. So we get a negative value which is -6, right? And this is less than 0. So yeah, so the intervals that we'll take is when x is less than -1 by 2, or when x is greater than 1 by 3, right? So these are the answers. I think that's enough for today. We'll do rest of the questions in the next lecture. Till then, take care.